Okay, now let's go over to the group. We've talked about the period. Now let's go over to the group. All right. So in some groups, the elements display very similar chemical properties, and some of the groups are even given special names to identify them. The characteristics of each group are mostly determined by the electron configuration of the atoms of the elements in that group. So let's look at the names and the summary of the names of the elements in the figure below. All right. So groups on the periodic table. A few points to take note about the groups. Number one, although hydrogen appears in group one, it is not an alkali metal. It is not an alkali metal. I told us last week, hydrogen can behave as a metal and as a non-metal. In most cases, it behaves as a metal, though you have H2SO4, H is the metal, SO4 2 minus is the non-metal. You have HNO3, you have HCl, you have H2O. In these instances, hydrogen behaves as a metal. Then the non-metal in hydride, metallic hydride, sodium hydride, NaH, magnesium hydride, MgH2, aluminum hydride, AlH3. In these instances, hydrogen behaves as a non-metal. So although it appears in group 1, it is not an alkali metal. An alkali metal starts from lithium, sodium, potassium, alkali metals. Number 2, group 15 elements are sometimes called the pnictogens. But for this is the first time you're hearing such. Group 15 elements are sometimes called the pnictogens. You can do more research on that because that's not our focus. Our focus is in JAM 2022, how these things relate and connect to the questions that will be set in the forthcoming exam. Group 16 elements, number 3, are sometimes known as the chalcogens. They are sometimes known as the chalcogens. Number 4, the halogens and the alkali metals, they are very reactive groups. And number 5, the noble gases are inert. They are chemically inert. They are chemically unreactive. Now, quickly, the following diagram illustrates some of the key trends in the groups of the periodic table. First, we see that the atomic radius increases down the group. It increases down the group. It increases down the group. Why? You have hydrogen has 1 shell. Lithium has 2 shells, 2, 1. Sodium has 3 shells, 2, 8, 1. Potassium has 4 shells, 2, 8, 8, 1. So if you see you have 1 shell, 2 shell, 3 shell, 4 shell. So the atomic radius increases as the number of the shells of the atom of the element increases. So that one is very explanatory, simplified. It's clear. The atomic radius increases down the group. Why? Because the number of the shells of each of the elements of that group also increases. So that's that on that. All right, before we look at the rest, before we look at ionization energy, which decreases down the group, electronegativity decreases down the group, density increases down the group. We can also say ionization energy increases as we go up the group, or we say it decreases as we go down the group. Now let's see. The table below summarizes the patterns or trends in the properties of the elements in group 1. Okay, now similar trends are observed for the elements in the other groups of the periodic table. Like I told us before, we are using group 1 as a reference point to look at other groups in the periodic table. Now, we can use information in the table below to predict, the table above rather, to predict the chemical properties of unfamiliar elements. For example, given the element francium is in group 1, we can say that its electronic structure will be that of radon and 7s1. Don't forget group 1 elements, that I think the last orbital configuration is s1. Hydrogen 1s1, lithium 1s2, 2s1. Can you see s1? Sodium 1s2, 2s2, 2p6, 3s1. Can you see s1? Potassium 19, 1s2, 2s2, 2p6, 3s2, 3p6. That's 18. Then 4s1. Can you see S1? So that of francium will be that of radon. Radon is a noble gas, a group 8 element. Will be that of radon and 7s1. So francium will have a lower first ionization energy than Kson, Cs. All right, now see. One general trend that is not shown is the melting point and boiling point. For the metals, group 1 to 13, the melting and boiling point increases as you go up the group. From the bottom to the top, it increases. Then for the non-metals, the melting and boiling points decreases as you go up the group. Okay, so you should also recall that the metals are found on the left of the periodic table, non-metals are on the right, and metalloids are found on the zigzag line that starts at boron. Okay, let's see the elements, and you see the electronic structure, and you see group 1 chloride. Now, in summary, we see that the atomic radius increases down the group, ionization energy decreases down the group, electronegativity decreases down the group, then density increases down the group. So for the group, atomic radius increases down the group, ionization energy decreases down the group, electronegativity decreases down the group. For the period, we see that electronegativity increases across the period, ionization energy increases across the period, atomic radius decreases across the period, but for the group, it increases down the group. All right, now we see the oxides of, okay, let's say the chlorides of group 1. You have lithium chloride, sodium chloride, potassium chloride, and you have the rest, Kson chloride, I think rubidium chloride also. Then group 1 oxides, you have a lithium oxide, and you have the rest oxide. So now let's see the summary of this. It said atomic radius increases as you move down the group, and I've explained that before. I said it increases as you move down the group because the number of shells of the corresponding elements down the group also increases. First, ionization energy. It decreases as you move down the group. It decreases as you move down the group. Then the electronegativity, it decreases as you move down the group also. It decreases as you move down the group. A melting and boiling point also decreases as you move down the group, while density increases as you move down the group. So this is just a simplified summary of the properties governing this periodic table that was established by Dimitri Mendeleev. So let's quickly see a summary, a recap of everything we've been looking at so far in the periodic table. So in our next class, we'll be looking at metals, their properties. We look at group 1. What is applicable to group 1? How soluble are they in water, in other solvents, and all that? We take group 2, we take group 3, and all that. Then the same we look for non-metals. We look at chlorine and its compounds, we see carbon and its compound, we see allotropy, we see isotopy, and all that. Then we'll now get to our mock exam. So let's quickly see a recap of everything we've been doing since last week. Elements are arranged in periods and groups on the periodic table. The elements are arranged according to their increasing atomic number. I told us according to their increasing atomic number. Number 2, a group is a column on the periodic table containing elements with similar properties, while a period is a row on the periodic table containing elements that have the same number of shell. Don't forget, the same number of electronic shell. Number 3, The atomic radius is a measure of the size of an atom, how big an atom is. The first ionization energy is the energy needed to remove one electron from an atom in the gaseous phase. Electronegativity is the tendency of atoms to attract electrons. Then across a period, the ionization energy and electronegativity increases. They increase rather, while the atomic radius decreases across a period. Then the groups on the periodic table are labeled from 1 to 18. Group 1 is called the alkali metals. Group 2, the alkali earth metals. Group 3, metalloids, where you have the semiconductors that possess properties of metals and non-metals. Group 17 is known as the halogens. Group 18 as the noble gases. This is for your large periodic table. And the small one we use in secondary school, now group 1 to 8, now is just a subset of the main table. The main table, group 17 are the halogens, group 18 are the noble gases. The elements in the group, they have similar chemical properties. Similar chemical properties. While the elements in the period, they have the same number of electronic shells. And lastly, the atomic radius and the density both increase down the group. Then the ionization energy, electronegativity, the melting and boiling points, they all decrease down a group. So thank you very, very much for your time. I'll send some past questions to the group after this class so that we can acquaint ourselves with the way questions come out in JAMB. Thank you very much for your time. So any other questions, still have questions bothering you on this topic or any other aspect of chemistry you don't understand, do let me know. Do chat me up privately, and justice will be done to those questions. All right, thank you very much.